Section 2.3 Graphical Misrepresentations of Data. This is the objective we'll look at in this section. We want to describe what can make a graph misleading or deceptive. In this quote, we see statistics being defined as the only science that enables different experts using the same figures to draw different conclusions. So let's look at an example. The data in our table represent the historical life expectancies in years of residents of the United States. We want to construct first a misleading time series graph that implies that life expectancies have risen sharply. Then we will construct a time series graph that is not misleading. So a time series graph simply plots the points and then connects them with a line. Notice in this one that our scale starts at 68 and goes up to 78. It's like we've sort of zoomed in on this portion of the graph, which is why it's misleading. It does seem to indicate a steep increase. However, if we look at a correct scale starting from 0 as it should, we see that the increase is not significant. In this next example, the National Survey of Student Engagement is a survey that, among other things, asked first-year students at liberal arts colleges how much time they spend preparing for class each week. The results from the 2007 survey are summarized on the next slide. We will construct a pie chart first that exaggerates the percentage of students who spend between 6 and 10 hours preparing for class each week. Then we will construct a pie chart that is not misleading. So here's our data, and here is our first pie chart. Notice, because it's three-dimensional, the pie that is at the forefront, which was the 6 to 10 hours segment, looks extremely large, much larger than all the other sections. But if we look at it in 2 dimensions, we see that it's not much bigger than the 11 to 15 hour category or the 16 to 20 hour category. Those three are fairly close. So here are some guidelines for constructing good graphics. First, we need to title and label the graphic axes clearly, providing explanations if needed. We include units of measurements and a data source when appropriate. Next, we avoid distortion. Never lie about the data. We need to minimize the amount of white space in the graph. Use the available space to let the data stand out. If scales are truncated, be sure to clearly indicate this to the reader. Avoid clutter, such as excessive grid lines and unnecessary backgrounds or pictures. Don't distract the reader. Avoid 3 dimensions. 3-dimensional charts may look nice, but they distract the reader and often lead to misinterpretation of the graph. Do not use more than one design in the same graphic. Sometimes graphs use a different design in one portion of the graph to draw attention to that area. Don't try to force the reader to any specific part of the graph. Let the data speak for themselves. Avoid relative graphs that are devoid of data or scales.